you have anything you wanted to say? Yep. Well, it's my pleasure to welcome you back to another semester of the Water Talk seminar series, and it's my pleasure also to introduce our first speaker, Nancy Doelger from the Bureau of Land Management in Casper, Wyoming. Excuse me. Nancy took her Bachelor of Science degree in Geology and Chemistry from Northern Arizona University and her Master's of Science in Geology right here at the University of Wyoming. She's been with the Bureau of Land Management in Casper as a petroleum engineer since 1987, and before that was employed by BLM as a geologist. She also has prior work experience with Gulf Oil as an exploration geologist with the U.S. Geological Survey and with Shell Oil Company. And today she's going to speak to us on the topic of coal bed methane production in the Powder River Basin. Nancy.
Thank you. First of all, I'll kind of give you an idea of where I'm coming from on this talk so that you can understand and ask. When you ask, I'm just going to give an overview. My title, as he said, is Petroleum Engineer with the BLM, but right now I'm working on as a team leader on an environmental assessment on coal bed methane production in the Powder River Basin. And my job on that environmental assessment is primarily kind of compiling and putting together the things that everybody else gives me. So I'm not actually doing the technical work, but I have done a lot of reading on the subject and may be able to answer some of your questions later on too. But this will just kind of tell you what coal bed methane is, why people are interested in it, and what the water issues are relating to it. Coal bed methane is currently generating a high level of interest in the oil and gas industry all over the country, and a lot of that interest is related to a tax incentive which was designed to encourage unconventional fuel development. It was part of the 1980 windfall profits tax. And since the price of oil has gone down, the price of the tax incentive has gone up. It's now worth 80 cents an MCF, 1,000 cubic feet of gas, which is in some cases almost as much or more as people are getting for the gas to begin with, so it is quite significant. To qualify for this tax incentive, wells have to be drilled by the end of this year. And so that's the reason why we're seeing so much interest right now, is people are trying to get these wells drilled before the end of the year to qualify for the tax credit. If they do get wells drilled by the end of the year, then those wells, production from those wells will be eligible for the tax credit until the year 2001. And the value of the tax credit is going up. So that deadline has been extended already from the first of this year once, and there are efforts to extend it again. Other factors in addition to the tax credit which are encouraging coal bed methane development include the existence of several economically viable coal bed methane projects in other parts of the country, primarily the Black Warrior Basin in Alabama and the San Juan Basin of New Mexico and Colorado. And there's also an anticipation that there will be an increased demand for natural gas to meet more stringent clean air standards, since natural gas is a cleaner fuel than either coal or oil has been shown to be. And another reason people are looking at it is there's less risk in an oil and gas sense in developing coal bed methane, because you know that the coal is there and the coal will contain methane. There's still uncertainty because you don't know. The coal quality is quite variable. The amount of gas in the coal and the coal gas quality itself can be quite variable. But you're not going to miss the coal when you drill a hole, which is what might happen if you drill an oil and gas well. You might miss the sand or something. And I'll put this first one up. So, this data was taken from a recent article in the Oil and Gas Journal. The resources are in TCF as trillions of cubic feet of gas. These estimates are very rough because there's not enough data on coal quality in many of these areas right now to really make a reliable estimate of what might be there. These are also gas in place estimates, and so this is not an estimate of how much gas might actually be recovered or what the economics of producing the gas might be, but the gas is probably there. To give you an idea of what these resources represent, the 39 trillion cubic feet of coal estimated for the Powder River Basin could supply Wyoming for 500 years at our current rate of consumption, could supply California's needs for the next 20 years at their current rate of consumption. Okay. This is a map of areas which are potential coal bed methane producers in the state of Wyoming, and this is taken from Dick Jones of the Wyoming Geological Survey. He has included pretty much every basin in the state which contains coal. Some of those basins were not included on the previous resource estimates, primarily the Wind River Basin, the Sandwash Basin extending up into here, and the Green River Basin are the primary targets people are looking at right now. Most of the drilling activity right now for coal bed methane is in the Powder River Basin. There are currently 14 wells which have been completed in coal beds, and of those 8 or 9 are producing. And there are a number of APDs on file, applications for permit to drill on file for 15 to 20 more wells. I don't have the exact numbers on these because a lot of them are confidential, not all of them are federal, and some wells are being completed in Fort Union sandstones adjacent to the coals. The gas is probably derived from the coal, but because it's being produced from the sandstone, it's a conventional oil and gas operation and doesn't qualify for the tax credit. And I'll talk about more of that, the difference between conventional and coal bed methane, a little bit later. There is some activity in the rest of the state. The Green River Resource Area in the Rock Springs District over has had 2 wells drilled, and the Pinedale District has had 1 well drilled in a unit, and Rollins has applications. There's drilling in Colorado, which may, if it looks good, they'll probably continue up into Wyoming, just north of the Colorado state line. This is kind of an all-purpose diagram of a coal bed. Methane is a byproduct of the coal maturation process. The volume of methane that is contained in a coal is related to the grade of the coal and the depth of burial and how much it remains in the coal. The methane is adsorbed on the internal surfaces within the coal matrix, and there's something on the order of the equivalent of 30% porosity in terms of holding ability within the coal bed for gas. Water typically occupies the fracture systems within the coal, and those fracture systems, this face cleat, butt cleat system, is typical of most coals around where they've been studied, and water typically does occupy that. Water is another byproduct of coal maturation process, and a lot of the water in the coal bed may have been derived from the coal maturation. It may not have migrated in from elsewhere. It may have actually been formed in place. In order to release the methane from the coal bed, the hydrostatic pressure on the coal seam has to be reduced, and this is done by dewatering the coal. Initially, gas production in these wells is very low or non-existent, and water production is very high. The water production typically declines relatively rapidly. The gas production increases and flattens out. The water production does not you don't run out of water, but it declines dramatically. However, if the wells have to be shut in for any reason, then the coal typically recharges and it has to be dewatered again before you can achieve your previous gas production. So, successful coal bed methane wells can be expected to produce for 20 to 30 years. The recovery factor for the methane is related to how low you can drop the hydrostatic pressure. And according to a talk I heard on the Black Warrior Basin in Alabama, recovery factors of 80% may be conservative in that area. But in order to get that amount of methane off, you have to almost reduce it down to atmospheric pressure. But they're close to the outcrop down there, whereas we're not. In a conventional gas well, the gas occupies the porosity within the rock, and it sits on top of the reservoir, forming what's referred to as a gas cap. And in that situation, you usually only perforate the well just in the gas, and it only produces gas initially. And then as the gas cap is depleted, you may start to produce water. And the gas production, it starts out high and declines. This is a production curve for a sandstone, Fort Union sandstone well completed in 1987. You have time on this scale and production in barrels or MCF on that. In this case, it's MCF because there's no water. So it's been producing for 3 years. They're still producing no water, and that's a fairly typical decline on the gas. This map shows current activity in the Powder River Basin. The stars indicate townships with coal bed methane activity. For reference, this is Gillette, Buffalo. This is Interstate 90. And the Recluse area up here has been the site of a number of completions in the Fort Union sandstones during the last few years. That production curve that I just showed you came from that area. But there are also currently several coal bed methane wells either drilling or being completed in that area. BTOP has 4 wells in the Rawhide area, and they've been producing since April. They're completed in the Wyandotte Coal, located just west of the Eagle Butte mine. 2 of the wells were drilled by the Department of Environmental Quality several years ago in connection with that Rawhide Village situation. These wells are right at Rawhide Village. They appear to be benefiting from their proximity to the mine in the sense that the mine appears to have dewatered the coal to some degree. I don't know if this is going to show up, but this is production for those 4 wells from April to September. Basically, they're making about 22 million cubic feet of gas per month and 40,000 barrels of water per month is the average for that period. These wells are only about 300 to 400 feet deep, and they're flowing. They're not having to pump them at all. And they're discharging the water down Little Rawhide Draw or whatever, which is one of the problems that we are coming up with. In both of the Rawhide area and the Recluse area, most of the activity to date has not involved federal oil and gas leases, and we have not included these areas in the environmental assessment area. This outlines what we're covering in the environmental assessment. Most of the activity right now on federal land has been in what they call the Big George coal seam, that's where we're working on the environmental assessment. The interest is due to the presence of an 80 to 200 foot coal bed in that area, the Big George seam. It's 1,000 to 2,000 feet deep. We prepared a total coal isopack for this area using 1,100 oil and gas wells. And based on that, we estimate that there are 380 billion tons of coal and maybe 27 trillion cubic feet just in that study area in coal beds that are 10 feet or greater in thickness. And we had 25 applications for permit to drill in that area. The big issue with this, the whole coal bed methane, is the water production. In the Powder River Basin, the water associated with coal beds meets the Wyoming State Department of Environmental Quality standards for surface discharge, which is less than 5,000 TDS. If current projects appear to be economic, there could be 200 to 500 wells in this area producing and discharging up to 2,000 barrels of water per day initially, possibly before the end of next year. And that's probably a worst-case scenario, but at the time we started this study, that was quite a reasonable estimate. And again, the reason that we're preparing the environmental assessment was due to the concern over the potential consequences of producing and discharging the water. We had public meetings, and we requested comments in September to identify the issues that we needed to cover in the environmental assessment. And right now, the main issues that were brought up were primarily what effect will production of all this water out of the coal bed have on the shallower wells and aquifers which the local residents depend on. Most of the shallower wells in this area are completed. The deepest is about 350 feet, I think. The coal bed that people are looking at right now are 1,000 feet or deeper. But there's still concern that producing this amount of water out of the coal could have some effect on the shallower aquifers. And also a number of the wells, particularly around this area where the initial drilling has been, are artesian and presumably powered by gas, which may have been derived from the coal beds. But there are shallower coal beds in addition to this deep one, which could have provided the gas. But the ranchers are very concerned that they're going to lose their artesian water supplies and have to go to pumping. And then what effect is the surface discharge of this water going to have on surface drainages, cattle and wildlife, and the quality of water in the Powder River? One of our earliest concerns was complaints by the state of Montana on the quality of water in the Powder, which is now entering the state of Montana from Wyoming. We haven't had any comments from them. We have notified them. We've not received any comments back. However, at this time, the quality of the water being produced from the coal beds is actually better than that's in the Powder River Basin right now. It's about 4,000 TDS. And what we've been seeing out of the coal beds is 1,500 to 3,000 total dissolved solids. So, and then another concern is what use can be made of this water rather than just discharging it and losing it. And it's suitable for stock. It does not, most of it does not meet irrigation purposes. But we're just going to be pumping it out and sending it on its way, and perhaps it could be used for something better than that. Some of the ranchers are planning on constructing stock ponds, but if this was to take place, there would be a lot of water for somebody to use. And the environmental assessment is scheduled for completion in early May of this year. We are accepting comments and any information that anyone can provide us up until that time, and then the environmental assessment will be available for public comment during the month of April, and any comments that are received will be considered in preparation of the decision record for that document. If anyone is interested, I can put you on the mailing list. We are going to send out the environmental assessment when it's completed to everyone on the mailing list. And that's all I have to say. If there are any questions? Yes?
Who's determining whether there are impacts on the shallow aquifers?
Well, that's a big unknown, and we have a hydrologist in our district who is working on this environmental assessment. Obviously, his part of the environmental assessment is going to be the largest part. There's not much data out there, and right now there's only, I believe, 2 wells producing out there right now. There are 2 wells which have been abandoned due to problems with the leaseholder, and then 4 wells which are waiting on approval of a surface discharge by the state DEQ. And so we don't have a lot of data on the water that's going to be produced, the gas that's going to be produced, and what effect there might be. One thing that we are trying to do is go out there and at least get a fluid level in all the wells and try and set up some monitoring system in the EA so that we can keep an eye on these shallower wells. But there's not a lot of data out there on what's going on. You've got 700 feet of shales and discontinuous sandstone channels between the coal that they're producing out of and these shallower aquifers. But whether there's a connection between those and the coal, nobody knows for sure at this time.
And so if your monitoring shows that there is a decline in water levels, or some of the shallow flowing wells quit flowing, then what?
We just had a discussion about that yesterday, what we can do. Why are we going to design a monitoring program if there's nothing we can do about it? One thing, we can at least advise people of what's happening. Basically, it's the landowner's responsibility to take anything like this to court. We can stop approving APDs if we can see that there is some impact. The state engineer and the state DEQ really have more jurisdiction in this area than we do in terms of approving these sorts of things. And so there may be steps that they can take. We actually have a question in to the solicitor as to relating to this about does this qualify under the Homestead Act as damage, and if so, can we cover it with a bond? Also, the surface owner has the option of trying to make an agreement with the oil company in the event that they feel that their well's being affected, that they can get some compensation from the oil company. I think the problem in that comes with who has to prove that the connection between the oil company pumping out the water and the problem in their well, and that may be difficult. But if we have some data, baseline data beforehand, then we might be able to provide some information on that. So, but basically it hasn't been decided what we can do. That's what we're trying to decide. Is there something we can do? So.
You mentioned this tax incentive for unconventional fuels expires on December 31st, 1990. What are the prospects for these companies continuing beyond that if the tax incentive was not renewed?
It depends on the company. We are getting different views from different companies. A number of, particularly the major companies, are saying that if they can't justify this without the tax incentive, they're not going to do it. A number of the smaller companies feel that they have to have the tax incentive to do it. And so if they don't get their wells drilled by then, or if it's not extended, they may not be able to.
So does the tax incentive just cover the initial development of the coal bed methane? Or in other words, is there a possibility for these companies to get involved with the project and then deem it to be uneconomical after December 31st and abandon the wells?
That's potential, because part of the problem with the coal bed methane and has required special stipulations and regulations is frequently you don't know if it's going to be economic until you've produced it for up to 2 years. And in the case of units, we are requiring them to keep testing it until they actually find out if they have a viable project or not. But most of the companies that are coming in seem to realize that fact, though. And in fact, what they're interested in is having input from us, because we have things called paying well determinations, whereas there has to be economic justification for continuing to produce that well, which in a coal bed methane well may not occur for 2 years. So we kind of have to give them a 2-year period to test the well to determine if it can be produced. So, and there could be an extension, but the wells, basically, there's differences in interpretation of what will qualify for that deadline, too, whether the well has to be completed in producing, whether it has to be just drilled. There may be some further solicitor's responses required on that also. That may end up in court. So, yeah.
With all the gas and water trapped in these coal seams, are there anomalously high heads in these seams? And if so, reducing it to atmospheric pressure and taking that much water out in order to get the gas to evolve, is that going to cause, is there concern about structural subsidence and things like that?
Areas where this production has taken place, they have not experienced that. Some of these wells that we're drilling in this area, the 4 that they drilled within the study area that we're looking at, one of them was artesian, and it flowed a tremendous amount a day, but the rest of them they're having to pump. So even that is quite variable depending on where you are in the coal seam. And they were trying to test different areas in the coal seam just to see if there were an area where it was fractured and different types of areas and different completions, trying to see what might work best on producing it. But I think in most areas, like I said, at the mine, or the rawhide stuff, it is flowing, and it is artesian. But I think 3 out of the 4 wells that were drilled in the unit down in here had to be pumped, and then the last one flowed. But it flowed at something like 5,000 barrels a day. So a barrel is 42 gallons, if I didn't make that clear. So, yes.
I'm sorry I got here late. I might be hitting something you already covered, but can you tell what was the reasoning behind doing an environmental assessment instead of an environmental impact statement on it?
The purpose, well, we are trying to decide if an environmental impact statement needs to be done, and that's more or less the purpose of doing the EA, to see if there are significant impacts. Then if we determine there are significant impacts, then it will be extended into an EIS, and the document that we produce with the EA will be the draft EIS document. And we have done all the public meeting and announcement requirements that would accompany an EIS in the event that it turns out the impacts are significant and an EIS is required. So.
And would significant impacts be water level declines in the shallow water?
Yes, that is one of them that has to be considered. However, the problem with that is I don't know if you'd see that for a while after until you started producing these. So, but that is one of the impacts being considered. Yes.
I had two concerns. The first was, is anybody worrying about what the long-term impact of this water being produced in the streams and its contamination of shallow aquifers? And the other thing is are these waters being produced loaded with hydrocarbons that are a problem?
No, apparently that does not seem to be a problem from other places and from here, the tests that they've run. I don't know that all of them have been, like I say, we haven't started producing out of this area enough to do much testing, and I don't know how thorough the tests are that they've done. The DEQ is kind of responsible for that aspect of it, but there is no indication at this time that there are significant hydrocarbons in there. And there is concern for sinking back into the shallower aquifers, and that's one of the issues that were brought up at the public meetings and that we are trying to cover in the environmental assessment. At least the environmental assessment is just going to make some kind of assessment of what the impacts, what might be, how severe they might be, and what probability there is of them being that severe. We're kind of looking at it as a worst case, and then what probability there is of that worst case happening. The decision on the impact, and like I say, I'm involved in preparing this environmental assessment. There's a team of people, the hydrologists, geologists, and the wildlife people and everything. And we write down what we think are the impacts, but the resource area manager in Buffalo is the person who makes the decision on what kind of impact. But then that decision is appealable, whether it's a significant impact or not. So that's how this process works, and that is being considered. Yes.
You mentioned the total dissolved solids for the water produced from the coal beds ranges between 1,500 and 3,000.
Today.
That was less than the average of 4,000 for, is that surface water?
In the Powder River.
So what about the shallow aquifers that Pete was talking about? What's a typical range of total dissolved solids that might be impacted by the seepage from this water?
The ranges I've seen, I think, for one company did go down and just test all the sands on the way down right in the middle of that area, and I think they were down around 750 up to 1,100 or 1,200, and then up beyond that. And I think I do have some numbers. I have some of the tables and stuff from the environmental assessment, and if you would like afterward, I could try and pull that out and give you a better idea on that.
So there would be a potential for an increase in the shallow aquifers there. Do you remember, as part of the totally dissolved solids, what are some of the major constituents of that?
It's primarily bicarbonates, which is somewhat typical of a coal, apparently. The coals are, and rather than chlorides, it's more bicarbonates, and that's about as extensive as I could get into that. So. Both the state engineer's office and the state DEQ have, I don't think they've presented any papers on this, but they have been very concerned with this and following along and attended a number of meetings, and they might be able to give you more specific information on that. But, and like I say, I do have some more additional information on that if you wanted to see afterward.
Am I to understand then that the discharged water is drinkable?
It is for stock. It meets the qualifications for stock. And I think with treatment it might be acceptable for people. I've been told that. Yes?
I know that the state engineer is concerned about the fact that the produced water is not being put to a beneficial use. And so from that standpoint, who actually certifies for the drilling of the well? Is it the Oil and Gas Commission, or is it the state engineer, or is there? I know there must be a conflict there, and I haven't asked the state engineer which way it is.
In terms of the way it's working right now, on federal lands, you have to have a federal approval on your well, and the Oil and Gas Commission has to give you approval on all wells, federal, state, and fee. And the state engineer is requiring a water well permit on all of these wells, and then the DEQ is requiring a surface discharge permit, MPDES permit, on all of these wells. And so everybody has a hand in it, but there are limitations as to what you can and cannot approve. And for instance, we don't. I'm not quite sure. I'm in the learning process on all of this regulatory part of this, but apparently we are obligated to approve APDs unless we can show there's significant cumulative impact, and then we're supposed to come up with mitigating measures. But it's very difficult for us not to approve it because they have won the lease and they have the right to explore it based on that lease. But we can write in mitigating measures which require them to do certain things to mitigate the impacts. So, I guess the state DEQ really has, if it meets the water quality for surface discharge, then they don't have any recourse but to sign those permits. Now, the state engineer has just now approved, I think, the first permits related to this, and they attached a number of stipulations, and they approved the permits for a period of 1 year, which are then potentially renewable. But they are requiring the operator to monitor the surrounding wells and kind of putting the burden of monitoring on the operator. And they intend to require a monitoring well for each certain number of wells that are drilled in a project. So,
How are they, did he put any stipulations in terms of, because I know he's concerned about the idea of putting it to beneficial use, and of course dumping it down the draw is not a beneficial use, and I know he's wrestling with
I don't
that
think
one.
anybody can require that, and that's, interestingly enough, too, the state engineer has ruled that pumping the water to produce the methane is a beneficial use. So, and I know that's a concern that we had, was trying to put this water to use and trying to encourage people to look at what uses it might be put to, but I don't know that anyone has the right to require that they put it to use. Another alternative for this water is to re-inject it. However, that requires re-injection into an exempt formation, which would be 5,000 to 10,000 TDS, so you would be contaminating the water that is usable, at least for some purposes at this time. So that's not a very good alternative. Yes?
Couldn't they re-inject into the Big George seam off-site so that they're to limit the extent of their drawdown?
That's something that we've discussed, but really, again, this is a new area. I don't know how far away they would have to re-inject in order not to just be pumping water back into what they've taken out, and unless they get the water out there and be able to produce the methane. And so I don't know how far away you'd have to go. And the other topic on re-injection is it possible to re-inject that volume of water? And so, but if you were to re-inject it in the Big George and just push it right back into the area you just reduce the pressure on to produce, then you would probably never achieve any kind of economic production on the gas. So that is a topic that's come up.
Might enhance your gas flow too. Get it right.
Well, if you can keep the pressure low enough, it might. But you got to get the pressure down, and that's the main problem with producing this, or the main requirement. Yes.
What about creating the same hazard as they had with the Rawhide subdivision? Is there any way to control exactly where the methane comes up once you dewater it?
Yeah.
Ranchers and people in the area.
That's been some concern, but when you do drill the well and start lowering the pressure in that area, you're making a pressure sink, and so the flow does tend to be toward that pressure sink to come up the hole. And I had a report, there was a person working, I believe it was the state DEQ, the Land Quality Division, and he was preparing a report on the Rawhide situation, and they had a number of causes that they thought caused that problem, but they believed that the problem in Rawhide happened, the gas started coming up before the mine dewatering reached that area. And so, and I don't know, they think that maybe that earthquake in that area may have caused some changes and there may be a pressure differential. That area, and the Recluse area is also another anomalously high gas area. They had gas, the reason people started drilling in there looking at these sands is because they've had gas kicks in a number of wells in that area and blowouts and stuff when they go through Fort Union. So there could be that potential in some areas, but I think your flow is going to be towards your wells if you start producing it rather than up. And also, there's typically shales and things in between which would prevent some of that migration. Although since there is apparently gas in some of the sands up the hole, which is probably from coal, there is some gas migration already before this was even undertaken. So.
What's going to be the density of wells required to produce from a field like that?
There's
Is it 1 per square mile or 1 per?
160 acres is what they're trying. They're not sure that they can dewater it effectively on that basis. It may go smaller than that too, which would be 4 wells per mile. It could go down to 40 acre spacing, which is 16.
That's pretty dense.
That's pretty typical oil field density for a number of formations. And that's sort of the default spacing at the Oil and Gas Commission for fields is 40 acre spacing. So.
Any other questions for Nancy? No, thank you very much.
Thank you.